Hey guys, so in my previous video we downloaded sector and industry data for tickers. I've been doing this for a while, so I've collected data for a bunch of stocks that I'm going to call in. So I'm going to call in that list, and then I'm also going to use a database that I keep to calculate sector performance, and I'm also going to try and find sector leaders. And when I mean leaders, I mean stocks that have outperformed their sector throughout time. So in this database, I think my database goes back to 2015, and I have videos on how to keep a database. So if you watch the video, I keep the exact same format for that database I'm going to call in. And here are some of the packages that we're going to require. So first off, I'm going to call in the list where I keep all the sector and industry data for each ticker. So I'm going to list files. So wherever you keep that data, you're going to set this path here. And then I'm going to use full names equals true. So like I said, I usually try and update this every month for the tickers that I don't have, but you can watch the previous video and then you can download the data that you need for the tickers you requested all in one shot. The next thing I'm going to do is I'm going to read those files in. So I'll pass the file paths as a list. I'm going to remove file. And then I'm going to use do call rbind to row bind these files together. So the list looks like this. We have ticker, what sector they're from, and then what industry they belong to. For this video, I'm just going to focus on sector, just because there's fewer than industry. You just have to switch a couple of things to make this work for industry. So for sector, I'm going to extract unique sectors from this file. So here it looks like we have 16 different sectors, which are these here. The next thing I want to extract are the ticker names. So I'll set this here. So currently in this list, we have about 15,000 different tickers. Now we need to narrow down our search. So I'm going to apply a volume penalty so that I can exclude penny stocks and other stocks that do not meet my dollar volume criteria. So here I'll apply a volume penalty. I'm going to go ahead and call my database, and this is where I'll get my volume data from. And I'll use pb_lapply, which I'm going to have to require as well. You can use lapply, but I always like to get a progress bar. So I'll pass in the tickers. And then I'll write my function to call in from the database. Alright, so the driver is going to be db driver sqlite. I'm going to establish my connection. Set in this driver db name. It's 2020 0621. Get symbols. So you're going to call in whatever you named your database. So now I'm going to try and send a query to my database to extract that ticker's data. So I'll use try db get query, pass in my connection, then I'm going to use paste 0, and it's select all from get symbols, which is my database name, where ticker matches. Here before the quotations, insert a single quote, and then after the quotations, use a comma, x, comma, parentheses, single quote, and then a semicolon. Then you're going to want to disconnect from the database. So here I'm going to test if my query did not yield any results. And only run them for cases where it did find data. So here I'm going to calculate dollar volume, which is going to be my data volume column multiplied by my adjusted column. I'm going to exclude any NAs. And only going to return cases where dollar volume is greater than 0. And instead of having the whole array, I just want the average dollar volume. So it'll be a single value that's returned. Change the column names of dollar volume, set to the ticker name, and then transpose dollar volume and return dollar volume. Alright, so I'm going to run this. Alright, so not so bad, a couple minutes. I'm going to pause it here and then continue when this is done running. Almost 4 minutes to calculate dollar volume for 15,000 tickers. So now that we have a list of volumes, I'm going to row bind them by running do call rbind vols. Take a look at the first iterations of vols. So we do have dollar volumes for some, but for some it couldn't calculate them for some reason. So I'm gonna NA omit them. So that we get complete cases. So there was quite a few. Our list shrunk, but still manageable. Right now I'm gonna trim down my dollar volume data because I only want those with a dollar volume greater than 1 million. So I'll write vols greater than 1 million. Go ahead and run that line. You could change this to whatever you like, but I only want ultra liquid. So now we have close to 3,600. I'm going to get the tickers that meet that requirement by running this row names of vols. Alright, so now that we have trimmed down our tickers, I want to extract sector information for those. So what I'll do is I'll subset my files data frame here by running files ticker in all ticks. So all this line is doing is trimming down our files that contain what sector each stock is from to match my trimmed down tickers from our dollar volume series. So we run that. Now we have the same observation here. Alright, so we'll clean this up. All right, so in this function, I'm going to pass in a sector, say healthcare. And what this function will do is it'll return the sector performance for a 5-year period, a 1-year period, 3-month period, 1-month period, a week period, a day period, and then we're also going to calculate the advancers, decliners, and those that returned unchanged for the day. So we'll write ticks, and we're going to extract all the tickers that are in this sector. So we'll subset our files. Sector matches our sector that we're passing through. So for this example, I'll pass in healthcare. So here we have ticks. So we have 645 different tickers in that sector. We're going to convert that to character and then get the data from our database. So I'll use pvlfi as list all of our tickers. Our function will pass in one ticker at a time, call in our database. I'll just copy these. There might be some tickers where we don't find any data, so I'll handle that. So if the number of rows does not equal 0, then run the following. So the first thing I'll want to do is convert this to an XCS object. And I only want to extract the adjusted column, and then order by as date, data frame date, and the format is 4-digit year, month, and then day. And then if we encounter NAs, I just want to bring the last observation forward. So I'll write NA LOCF, change the column names of DT to the ticker name, and then find the daily returns by running ROC. DT type will be discrete, and then fill in any NAs with 0. And then finally just return DT. Alright, so hopefully everything is right, and we'll go ahead and run this. Having a database is a little bit quicker than just calling it from Yahoo Finance. So 15 seconds for 645 different tickers. Let's see if it found all of them. So here I'm just going to extract the ones that do have data, and then I'm going to row bind them all. So if the length is greater than 0, I want to keep. So our data list currently has 645. So it looks like it did find all 645 different tickers. Alright, so now I'm going to merge them or combine them by running do call merge data. Now let's take a look at our data. So everything looks okay, but I'm going to go ahead and make the index unique in case there's some time zone errors. Alright, so now we're going to extract 5 years worth of data by running data paste 0. We're going to pass in system date and then subtract 5 years. So it'll start from 6/21/2015 until all available data, which was June 19th, I believe, of 2020. So we'll run that data. All right, so if there's any NAs in our data, I want to replace those with 0. If there's infinites, I'm going to replace those with 0. If it's not a number, I want to replace those with 0. And then I did not clean this particular database, so chances are we're going to have some daily returns that are really abnormal. So I'm going to eliminate any returns that are greater or less than 100% in a day. Let's make that 50%. We're going to exclude any points it returned greater than 50% by subsetting those with 0. Since we're getting sector performance, it'll really skew the performance tables. And then if they're less than 0.5, I'm going to replace them with 0. And then again, that's only because I haven't cleaned this database. Alright, so if we take a look at our data, everything looks complete. Next, I'm going to count the number of stocks in this snapshot for our report. Store that in N assets as a data frame by counting the number of columns in our data. And then changing the column names to number of assets. All right, so this is to get the 5-year performance. I'm going to sum the columns. And then return a data frame with the average of those column sums. I'm going to round that to 4 decimal places. And finally, just change the column name to 5-year RET. So our 5-year return for that basket of 645 different tickers was approximately 3%. All right, now we're going to calculate the same thing, but for 1 year. And I'm going to copy this. Replace the 5 with the 1. So we're trimming down our data. Copy these lines here. And then change these to DF2s. And change the 5 to a 1. So here we'll run these lines. Check DF2. So our 1-year performance for the sector is almost 14%. Next, I'm going to copy these lines. And we're going to repeat the process for the 3-month. Change this to months. So we're going to go back 3 months from today's date. change all the DF2s to something else. And here we'll calculate the 3-month return. Check DF3. So for this basket, our 3-month return was close to 41%. So we'll repeat the process, and this will be for the 1 month. Here we'll change it to DF4. Run these lines. Check DF4. I forgot to change this 3 to a 1. Rerun that line. Check DF4. So the 1 month return was almost 4.5%. All right, now we're going to calculate the 1 week performance. So instead of months, we'll use days. We'll go back 7 days. Change these to DF5. Alright, so we'll run this data, check DF5, and the performance for the week was close to 4%. And then finally, for our 1-day return, our data is going to be the last observation, since these are returns. And change these to DF6. And then run these lines. So DF6. Alright, so now we're going to calculate advancers and decliners for 1 day. So all the positives are the advancers. We'll use a data frame, and here we're going to return the number of columns or data. Data is greater than 0. So positive, we have 286 advancers. I'm going to copy these lines. So here we'll do less than. These are going to be our decliners. And then for flat is data that equals 0. Alright, so we'll double check by adding 118 plus 241 plus 286 equals our total basket of 645. So all is good there. I'm going to rename the columns for each one of these data frames. These are decliners. These are unchanged. Alright, so now we're going to combine all these data frames, and that's what we will be returning. So So cbind, data frame. I'll insert the sector name here. So it'll be df1, df2, 3, 6, and then insert our advancers, decliners, those that were flat, and then the number of assets. Alright, so this is what it'll look like. Alright, so since this function is kind of long, I'm going to open a script. I'm going to copy my function, paste it in that new R document here, save this. And then to call it in, we'll just write sec fun.r. So now we have our function here. Alright, so we're going to use that function that we just created to get this data for all the sectors. So what I'll do is use lapply as list, pass in all the sectors in here, use function, I'm going to use a try just in case. Pass in our sector to our function, and then if it does not inherit any errors, I want to return it. Alright, so we'll go ahead and run this. Alright, so when this is done, I'm going to delete the empty list. And then I'm going to rbind that list. So there it encountered an error, but the program didn't crash, thanks to that try statement or function there. Alright, so we're going to go ahead and run these two lines. So now we have sector performance for 12 different sectors. The 1 day returns, well, for this one it looks a little off, but that's because it only calculated returns for 2 different tickers. It might be that we got rid of tickers in the sector when we subsetted our tickers with the dollar volume. So I'm just going to go ahead and get rid of this sector. So I'm going to subset SEC. I only want the number of assets greater than 10. So now there's 11 different sectors. So now I'll do a bar plot. We'll compare the 5-year return. Border, set that equal to true. names argument. We'll use SEC, sector names. Color, I'll use rich 12 equal. Kind of format my Y limits to the minimum of SEC 5-year, and then the maximum will be SEC 5-year. My title will be 5-year sector performance, and then I'm going to shrink my sector names a little bit so that they fit. So before running that, I'm gonna maximize this here. So I believe this is from Performance Analytics, I want to say. So we'll go ahead and retry this. Yeah, so this is from Performance Analytics. We'll require the package here. All right, so we'll zoom in a little bit. All right, so here we see the performances. All but one sector are in the positive. Energy has really gone beaten up these last 5 years. Excellent. So now we'll copy this. I guess we'll do the 1 week return. Here we'll change the title of it for 1 week. All right, so the best performing sector for a week was healthcare, then technology, and communication services. 4 sectors were negative this past week. All right, so the next function I'm going to write is to get the leaders in each sector. So I'm going to go to that script where we keep our functions. I'm going to write find leaders. Here I'm going to pass in what sector I'm looking in, and then MY, which is monthly or yearly. So here what I'll do is I'm going to basically copy a few lines from my previous function. So starting from the top all the way down to the positive and negative 50 here. So we're going to copy that, paste it here. And then depending on whether the user wants monthly data or yearly data, we're going to subset that data. So if the user selects M for monthly, data is going to become monthly column sums. And if the user selects a Y for yearly, it'll return the column sums for annual returns. All right, so depending on whether they choose M or Y, I'm going to extract the index, and then I'm going to try and find the ranks by running lapply as list, pass in our index as a list, and then what I'll do is, since I'm passing in the index, I'm going to extract that row for that date and then rank those. And then I'm going to use this list to find the top performers each and every period. So here all I'm doing is passing that date. And then we're going to transpose temp, order it in a decreasing fashion. And I only want the top 50. All right, so that's going to give us the top 50 stocks in each and every period, whether we chose monthly or yearly. I'm going to extract the row names to find the tickers. So we're going to use do call r bind lapply rank row names. So that's going to get us the top 50 tickers in each and every period. And then this will contain the unique tickers found in the top 50. All right, now to find the leaders, I'm going to use lapply as list, pass in the unique tickers, and then my function will be sum. So I'm going to try and find how many times did this ticker repeat in being the top 50. And those that rank the highest will be the leaders. And we're going to use str count, passing in the ticker and then comparing it to find tickers. So how many times did it repeat? Hopefully more than once. And then what I'll do is r bind the leaders, and then I'm going to order it. All right. So all I'm doing is extracting the top 50 tickers that outperformed each and every period, and then I'm trying to detect how many times did that ticker repeat, and extracting the most repeated tickers, and then subsetting our data and returning the top 5. So that completes our function. Go back to our main script. So as an example, I'll run find leaders, SEC, we'll try technology. And then whether it's month or year, we'll use Y for year. And see what that returns. So it looks like I forgot an S here. I'm going to rerun this function. We'll go ahead and give this another try. Another typo there. I'll give it one more try, hopefully without any errors. So according to our data set, these are the top 5 leaders in the technology space. So we will take a look at ST and F. And our data started in 2015. Let's take a look at shop. So ideally it should look something like this for outperformance. So since our data started in 2015, this stock performed extraordinarily well each and every year. Looks like we only had one down year. Let's take a look at RNG. Pretty nice shape. Great. AMD. Another 2000%. And ENPH. Close to 500% since 2015. So I don't know what happened here with this ticker, but like I said, it might be something to do with not having clean data in my database. But for these other 4, they look pretty decent, and this is for entertainment purposes. I'm not saying that these are going to continue to outperform, but you have a general idea of what tickers to look for in the technology space that are considered leaders. We're going to do all of the sectors. So I'll use LApply, pass in sectors for the list. And here you would change either if you want yearly or monthly, but I'll just do yearly for now. Alright, so now we're going to pass in all the sectors to get the leaders in each. Alright, it looks like we encountered some errors for some sectors, so I'll just go ahead and exclude. Alright, so we'll take a look at the first list. I'm going to write another brief function here called LU for lookup. In case you quickly want to look up a ticker and find out what sector it belongs to, we'll just do as character subset files ticker equals ticker, and then get the sector. Now we get the appropriate sector. So for our first list, these are all in healthcare. Take a look at CGen. Five-year return looks all right, I guess. We'll try KPTI. 5 years doesn't look so good to me. ACB. Five years. Looks like it had extraordinary returns up to March 2019, which returned negative 88%. So it may be that in this sector, since we're only counting the number of times it repeated or outperformed, it may be that there's no definitive count. So maybe all of these have weak counts for the number of times it repeated. So we'll take a look at another sector. And this might be industrials, maybe, or basic materials. So for basic materials, this one looks pretty good. Looks okay. So again, I'm not looking at total return. I'm looking for what ticker outperformed each and every year. So these are based off of ranks. It's not based off of total returns. Let's take a look at T-Rex. This one looks pretty good. Sand. This one looks okay. Alright guys, well, that's the end of this video. To do the same, but for industry, you just have to tweak a couple of things in our functions. And that would be starting off with these lines instead of sector, this would be industry. Same with the bottom function. Instead of sector, this will be industry. And then you would want to get the industry tickers by extracting industry from our files. So here we see how many industries we have. So we have 166 different industries. But essentially the same thing. Alright guys, well, let me know what you guys think. And as always, thanks for watching.